Hello. Hello and welcome to this video on the next set of problems on polynomials and theory of equations. Before we start the video, I would like to update something. The algebra book is now complete. By complete, it does not mean that it will never change, but the first revision is there. You can go to my website astravoker.org and you click at this link, second link, a variable in algebra. You note that the date is there, that is the build date. Whenever the build changes, the date will be updated. But the file will not have the date in name, so you need to take care of that. You click that link and you have the book here. You can download it for free and there is no cost. You don't need to pay me, and there is no hard copy. All you have got is this PDF. So download and read it as you wish. So now we can start this video. So we had done up to problem 170. Now we will do problem 171 to 180. So okay, let me close this. Now, as I always say, when I'm reading the problem, you should pause the video, and if you cannot solve the problem, then look at the solution. So without further ado, let's get started. Question 171 says that find the remainder when x to the power 2025 is divided by x square plus 1 into x square plus x plus 1. So what we do here is we look at the roots of the two factors, that is x square plus 1 and x square plus x plus 1. So roots are plus minus I and omega square. Now we let x to the power 2025 is equal to f of x into g of x plus ax cube plus bx square plus cx plus d, where gx is divisible by x square plus 1 into x square plus x plus 1. So how did we arrive at this remainder x cube plus bx square plus cx plus d is the product of x square plus 1 and x square plus x plus 1 is a polynomial of degree 4. So when we divide x to the power 2025 by a polynomial of degree 4, the remainder must be of degree 3. Okay. So now we have this remainder. So we set x is equal to I, and okay. So this shouldn't be I. This should become this. This should be written here. Okay. Now we substitute minus I also. Minus I will have the same thing. So we substitute I. It becomes minus AI minus B plus CI plus D. Now we compare the real and imaginary parts. The imaginary part would be 0. Okay. So if you substitute I in x to the power 2025, it would become I. I was wrong here. That is x to the power 2025 value of that. So we compare the real and imaginary parts. The real part would be 0, so B is equal to D. And the imaginary part would be C minus A is equal to 1. That is the imaginary value of this. Now we set x is equal to omega and omega square. So first we set omega. So we get omega is equal to, now if you see 2024, then 2024. Okay, let's see if it is 2023. We see, okay, 2025 is divisible by omega, so this would become 1. If you substitute omega here, it would become 1, and if you substitute omega square, that would become 4045. So this should be 1 actually. Okay, and this shouldn't be omega, but you get the idea what we are trying to do here. Okay, so we set omega, this becomes 1, and then we compare real and imaginary parts. This should be probably omega square. Let me think. Okay, if we substitute omega square, 4045. So 4044 is 1. So this should be omega square. We set x is equal to omega square. And we compare and real imaginary parts, and we then finally evaluate these things. We will get 4 equations, 4 unknowns, and then we have the remainder as x cube plus 2x square plus 2x plus 2. Now we look at question 172. 172 says that prove that there does not exist a polynomial p of x is equal to a0 plus a1x plus a2x square plus so on up to an x to the power n such that p0, p1, p2 are all prime numbers. Okay. So we can assume that the leading coefficient in px is positive, so that px tends to infinity when n tends to infinity, and p of n is greater than 1 for n greater than a natural number n, capital N. If x greater than capital N, p of x is equal to n x to the power n and so on up is equal to y greater than 1. Then that's the assumption we have made. Okay, then what we have is p of ry plus x. Now if we evaluate this, this would be ry plus x to the power n. Now note that in the expansion of ry plus x to the power n, only the term, last term, x to the power n will not have a factor of y. So that would become n x to the power n. And similarly, n minus 1 into ry plus x to the power n minus 1, only the last term would be independent of y. That would be an minus 1 x to the power n minus 1. So the terms independent of y would form this series again. So when you take the sum of terms here which are independent of y, the sum would be y. So essentially the entire series is divisible by y for every integral r, and p ry plus x tends to infinity with r. So you see we have infinitely many composite values of n. So we won't have all prime numbers. Now question 173 says that solve x plus 1 square root of a plus square root of x is equal to a for real x and a. This is a very straightforward problem. What we do is we bring x to this side and we square, we get a minus x whole square is equal to a plus square root of x. So this square root is removed. So we bring everything to one side, we get a square minus 2x plus 1 plus into a plus x square minus square root of x is equal to 0, which is the quadratic equation in a. So we have two roots, 2x plus 1 plus minus 2 square root of x plus 1 by 2. Okay. Now we let z is equal to square root of x. So a becomes z square plus z plus 1, and the other value becomes z square minus z. Once we have that, first we consider the second root, that is az square minus z. So from the given equation, what we have is square root of a plus square root of x is equal to a minus x, which would be greater than 0. Okay, that means a greater than equal to x, that is a greater than equal to z square. Now we have z square minus z is equal to a from this equation. This shouldn't be first, this should be second. Okay, once we have that, we see that minus z would be greater than 0 because z square minus z is greater than z square. So minus z would be greater than 0, that is minus square root of x greater than equal to 0. So this means that x is equal to 0, that is a is equal to 0. Now we consider the second root. So a is equal to z square plus z plus 1. So this is a quadratic equation in a. We solve to get the roots as minus 1 plus minus square root of 4a minus 3 by 2. Now if you see this, a is real. Okay, so z would be also real. Now what that means is this cannot be negative. 4a minus 3 cannot be negative. Okay, so we take only positive root. There should not be plus minus, there should be just p. So there just should be plus. So z is equal to minus 1 plus square root of 4a minus 3 by 2. Now, since z is greater than 0, this 4a minus 3 should be greater than or equal to 1, otherwise z would become negative. So once we have that, we have a greater than or equal to 1. And thus x is equal to z square is equal to 2a minus 1 minus square root of 4a minus 3. So we have solved that. Now we solve question 174. Solve x square minus square root of a minus x is equal to a for real x and a. So what we do here is, like the previous problem, we bring a to the left side, or left side. That should fine. So x square minus a, and we bring this to the right hand side, and then we square both sides and we obtain the equation a square minus 2x square plus 1 into a plus x to the power 4 plus x. So if you solve this, you get a is equal to x square plus x and x square minus x plus 1. What this means is x is equal to minus 1 plus minus square root of 1 plus 4a by 2 and 1 plus minus square root of 4a minus 3 by 2. So clearly a would be greater than 3 by 4. Okay, because 4a minus 3, if it is less than 3 by 4, 4a minus 3 would become negative and x won't remain real. So that is one thing. And the second thing is, if you look at the first solution, then we need to discard the negative root. Why this negative root should be discarded is because if you take the negative root and you put in here, it won't work. Now we solve the next question 175, which says that square root of a minus square root of a plus x is equal to x for real x and a. So following similarly, we obtain the equation a square minus 2x square plus 1 into a plus x to the power 4 minus x. So our a is x square plus x plus 1 and x square minus x. And now you can solve and you can get the roots. Question 176 says that the polynomial ax cube plus bx square plus cx plus d is equal to 0 has integral coefficients ad odd and bc even. Prove that all the roots cannot be rational. So we let the rational roots of the equation as alpha 2 by alpha 1, beta 2 by beta 1 and gamma 2 by gamma 1. We put these roots into the equation and write in the product form. So the equation can be written as k into a1x plus alpha 2 plus b1x plus beta 2 plus gamma 1x plus gamma 2. Okay, there is something wrong here. Okay, the thing is 176, what is wrong here is the plus sign should not be there. If you put plus sign, then the degree won't be complete. Okay, so assume that this is multiplication. If you multiply, you get alpha 1 plus beta 1 plus gamma 1 is equal to a. Alpha 1 beta 1 gamma 2 is equal to b plus alpha 1 beta 2 gamma 1 plus alpha 2 beta 1 gamma 1, and c is equal to alpha 1 beta 2 gamma 2 alpha 2 beta 1 gamma 2 alpha 2 beta 2 gamma 1, and d is equal to alpha 2 beta 2 gamma 2. Now if AD is odd, all of alpha 1 alpha 2 beta 1 beta 2 gamma 1 gamma 2 must be odd. This implies that B and C, you look at B and C, they must be odd as well, which is a contradiction. So our assumption that the roots are rational does not hold true. Question 177 says that if roots of x to the power 4 plus x cube plus bx square plus ax plus 1 is equal to 0 has real roots, then find the minimum value of a square plus b square. So this can be a tricky problem because we have to observe something. If you look at this equation, it's a symmetric equation. So you study the symmetric equations of degree 4 later on, all of degree 6 and so on. Coefficient of x4 is 1 and constant coefficient is 1. Coefficient of x cube is a and coefficient of x is a, and coefficient of x square is b. So the coefficients are symmetric, 1 1 and a and b. So in such case, f of x will be equal to f of 1 by x. So we substitute x is equal to 1 by x. So the equation becomes x square plus ax plus b plus a by x plus 1 by x square, which we can write as x plus 1 whole square, x plus 1 by x whole square plus a into x plus 1 by x plus b minus 2. Now we substitute x plus 1 by x is equal to z, which would be greater than or equal to 2 from arithmetic AMGM inequality. We have now the equation as z square plus az plus b minus 2, which would be equal to minus a plus minus square root of a square minus 4b plus 8 by 2. Now this is greater than or equal to 2 here. This is not d, this is z, this is wrong. This is not discriminant, this is the roots of this equation. So we have the roots, and now we multiply 2 with 2, so it becomes 4. We bring 8 to this side, 4 plus a. We square both sides. We get a square minus 4b plus 8 greater than or equal to a square plus 8a plus 16. Okay, so a square will get cancelled, 8 will become here and get cancelled. So finally you will have minus b greater than or equal to 2a plus 2. So a square plus b would be greater than or equal to 5 square plus 8a plus 4. Now this is the quadratic equation, and we know that for a quadratic equation minimum value is minus d square by 4a. So you take this equation, if you look at the discriminant of this equation, it would be 8 square minus 4 into 5 into 4, that is 80. 64 minus 80 would be minus 16. So minus d square would be 16 and 4a would be 20. So the minimum value of a square plus b square is 4 by 5. Next problem might seem a bit complicated, but we'll try to solve it. If the coefficient x bar k upon expansion and collecting the terms of the expansion, that is this expansion is ak, then find a0, a1, a2 and a2 to the power k. Excuse me. So this problem can be a very nasty problem. If you try elementary solutions, it wouldn't work. You have to get creative in this problem. Okay, let's look at the solution. So we see x minus 2 whole square is x square minus 4x plus 4, which is equal to x minus 2 whole square minus 2. Okay. Now this is x square. Sorry, this is x square plus 4 minus 4x plus 4. This is x minus 2 whole square minus 2, which is x square minus 4x plus 4. So you see that the term involving the power of x to the power 0 will always become 4 as after the expansion, and before squaring the constant term will always be 2. So see, when you square this becomes 4, and then before squaring it, since minus 2 will be subtracted, it will become 2 again, and then you square this will become 4 again, then subtract 2, then it will become 2 again. So you see, the coefficient a0 would be 4 after squaring, because finally we are squaring. The final operation is squaring. So coefficient of a constant term would be 4. Now a1 is coefficient of x. Now if you look at this, x minus 2 whole square minus 2, that becomes x square minus 4x plus 2. Now if you perform a square, then we see that coefficient of x will be 4 times, because it will get multiplied with 2 twice and get added. So if you square this, the 4 will get multiplied with 2 times, because 4 into 2 and 2 into 4. So you see that coefficient of a1 would be minus 4 to the power k. Similarly, we can find that on first expansion, a2 is equal to 4 minus 1 by 3, that is this. Okay. On the second expansion, it is 4 plus 4 square. So the coefficient of a square after expanding this, okay, that is 4 to the power 3 minus 4 to the power 1 by 3. On the third expansion, it will become 4 square plus 4 cube plus 4 to the power 4. That is 4 to the power 2k minus 1 minus 4 to the power k minus 1 by 3. And proceeding similarly, we find the term ak as 4 to the power 2k minus 1 minus 4 to the power k minus 1 divided by 3. So the coefficient of a to the power 2k is 1 because the coefficient of highest powers of x, which will remain constant on any number of squaring. This should be a2, not ak. This should be a2. Okay. Question 179 says that prove that the equations x square minus 3xy plus 2y square plus x minus y is equal to 0 and x square minus 2xy plus y square minus 5x plus 7y is equal to 0 imply the equation xy minus 12x plus 15y is equal to 0. So we have two equations. We take the first equation, that is this equation, and factorize this. This becomes x minus y into x minus 2y plus 1 is equal to 0. So either x is equal to y or x is equal to 2y minus 1. We substitute x square is equal to y in the second equation and we get y is equal to 0, which satisfies the third equation. Now we set x is equal to 2y minus 1 in the second equation. We get y square minus 5y plus 6 is equal to 0. So y is equal to 2 and 3, which gives x is equal to 3 and 5. So we will have two pairs and both these pairs of values satisfy the third equation. Question 180 says that if a and b are integers and the solution of the equation y minus 2x minus a is equal to 0 and y square minus xy plus x square minus b is equal to 0 are rational, then prove that the solutions are integers. So from the first equation we have y is equal to 2x plus a. They put this in the second equation, we get 3x square plus 3ax plus a square minus b is equal to 0. So x is equal to minus 3a plus minus square root of 12b minus 3a square by 3. Since the roots are rational, the discriminant must be perfect square. So 12b minus 3a square is equal to c square, where c is in the set of integers. Now c will be a multiple of 3 because there are two ways. Left hand side is a multiple of 3. Okay. So since this is rational root, this 3 must divide this. Okay. Now that's why c must be multiple of 3. If a is odd, then c is odd. Okay. And if a is even, then c is even. Thus a and c have the same parity. This should be has. And minus 3a plus minus c is always even. Okay. So suppose a is even, then c is even. So this becomes even. If a is odd, so this is odd. And c is odd, this is odd. So odd plus odd is even and odd minus odd is also even. And therefore, it will be a multiple of 6. This implies that x and y are integers. So with this, we come to the end of 18th set on polynomials and theorifications. It will be a long while before we complete this. There are lots of problems. So thanks a lot for watching, and do not forget to subscribe if you are not subscribed. Like the video, share it as much as you can because that will help me. I feel motivated when I look at analytics. Someone has liked the video, someone has shared it. So it also increases the reach of the video, which is the entire objective of this video, to help as many people as I can, or rather we can. As a community, you should try to help each other, and by sharing, liking and subscribing, the reach increases. That's how YouTube works. If you have any questions, let me know in the comments, and as always, you can download the book. I will fix the typing mistakes, and the book will be updated. So once again, thanks a lot for watching. Enjoy.